5a is slightly different, because if you look at it, we don't have something that fits nicely into our inverse trig pattern that we're seeing in question 5. Well, what are our inverse trig functions? Let's have a quick look at them, right? We have a few. The first one we have if we differentiate sine inverse of x, what do we get? We get 1 over the square root of 1 take x squared. What about if we differentiate cosine inverse of x? What should we get? We get negative 1 over the square root 1 take x squared. And lastly, if we differentiate tangent inverse of x, we get 1 over 1 plus x squared. So, do we see anything that looks like these in our expression over here? Well, no, we don't really. But maybe we're just not looking at it properly. So if I expand this, right, I get 1 over the square root of x minus 2x squared. Well, what have I got on the bottom now? This is a quadratic expression, right? And if I want to have this expressed as a square, I've got this nice tool called completing the square. So I can actually complete the square for the denominator here. So this is 1 over, so to help me complete the square, I'm going to factorize out this negative 2. I get x squared take a half x. And then if you recall completing the square, this is 1 over the square root of negative 2, and then this is going to be x minus a quarter. Why a quarter? You take negative a half and divide it by 2. So you get negative a quarter squared. And then, when we square this, right, we'll get a positive 1 quarter squared term appearing that we don't have up here. So we need to subtract that away again. So a quarter squared is 1 over 16. So we subtract that away. And then integrate with respect to x. Okay, so we can fix this up so that it looks how it used to. And this is 1 over the square root of 1 over 8 minus 2x take a quarter squared dx. So, how to do this? Well, if you look at our formulas again, you notice all of these have 1 minus something squared, 1 minus something squared, 1 plus something squared. So, I don't want this term here, this 1 over 8. So, I'm going to get rid of it the same way I got rid of the negative 2 for my working. I am just going to factorize it out the front. So, this is equal to the square root of 1 over square root of 1 over 8 times, now I've pulled out a factor of 1 over 8, so I get 1 minus 16 x take a quarter squared dx. Well, this one is quite nice, 16 x take a quarter squared. Remember, 16 is just 4 squared. And since I've got squared squared, well, no point writing the same thing twice, right? Us mathematicians, we're quite lazy, so we'll just square the whole thing. And now we're into a position where it's 1 minus something squared. In fact, it's even better than that, because I can, now that it's all inside the one bracket, I can just rewrite this as 4x minus 1. So actually my expression's quite nice now. So, 1 divided by the square root of 1 divided by 8. That's actually just the same thing as square root 8 in the numerator. And then I get, so integrate 1 over square root of 1 minus 4x take 1 squared dx. What does this one look like? Well, if we go back to our rules, our formulas, 1 over the square root of 1 minus something squared, I think we're talking about this one here, right? So, how are we going to do it? This is then equal to root 8 sine inverse of 4x take 1. And then, of course, because there's this 4 in front of the x this time, I don't want that to reappear. I'm going to divide by 4 and then add my constant of integration. So root 8 over 4, this is, you can think of this as 2 root 2. So root 8 is the same thing as 2 times square root 2. This is the same thing as 2 squared. So one of these 2's will cancel, and so you get root 2 over 2 sine inverse of 4x take 1 plus c. And that is your final answer.